So what I'm going to do is I'm going to walk through some examples about how you write a complex number in ModArg form. So let's do this first one, 1 plus 2i. So the first thing I'm going to do is I'm going to work out its modulus. So its modulus is the square root of x squared plus y squared. So x squared is 1 plus y squared is 4, so we get root 5. So that's its modulus. Now its argument is we're going to have to use tan theta equals y on x. So y is 2, x is 1, so you get theta equals inverse tan of 2. And it's probably worthwhile when you do these, just have a bit of think about where this is. So 1 plus 2i is 1 across 2 up, so it's up in this first quadrant here. So I'm going to get a positive argument here. So if I do this on my calculator, we get, it's about 63 degrees. Let's just round it to nearest whole degree. So that means we've got the modulus, we've got the argument, so we can write this complex number here is equal to root 5 cis 63 degrees. Let's have a look at this one over here. So let's sketch it just to get an idea where it is. So it's minus 1 across to the left, minus 1 down. So it's over here. So when we get the argument, we need to be careful that we measure it as this way here. So let's do its modulus first. So its modulus is equal to the square root. Remember, modulus is just the distance it is away from the origin. So it's found by using Pythagoras. Square that, we get 1. Square minus 1, which is a coefficient of I, we get 1. So we get root 2. Now, tan theta is y on x. So it's minus 1 on minus 1, which is 1. So we get theta equals inverse tan of 1. And if we do this on our calculator, we get pi on 4. But we know that can't be our answer because pi on 4 sits up in this quadrant. So what we've actually got is we've got that angle there. So I need to find this angle here. So that angle we know has got to be 135 degrees, but it has to be negative because it's underneath the x-axis. So that means the argument of whatever your complex number is, let's call it z, is negative 135 degrees. Now you could write that in radians. So that's negative 3 pi on 4. 3 pi on 4. So how do you write that complex number? Complex number must be equal to root 2 cis minus 3 pi on 4. Close brackets. So this one here, if I graph it quickly, so negative 1 that way, root 3 up. Okay, so we're going to have an argument that goes this way. It's just nice to think about. So let's work out its modulus. So modulus equals the square root of x squared, which is 1, plus y squared. So the square of that is a 3. So we get a nice modulus in this case, which is a 2. The argument is tan theta is equal to y over x, so it's root 3 on minus 1. Do this on your calculator, you should get an answer of this as 60 degrees. Well, sorry, you'll get 120 degrees. So it'll probably give you that on your calculator, so 120 degrees. That matches up with my diagram. So what that means, in 120 degrees, we can write as 2 pi on 3 in radian measurement. So our complex number, we can write as 2 cis 2 pi on 3.